What's up, friends? Welcome. It is March 14th, 2023. And we are sitting here hanging out in the wake of a pretty big announcement from GMAC that the GMAT later this year will change more fundamentally than it has since it went from a paper test to an online exam. So, biggest change in GMAT history since then. And so, a lot of stuff's up in the air, and there's a lot of stuff we don't know yet. So, what we're going to do tonight is we're going to go with one thing that we do know. And so, I wanted, because it looks like data and sort of data analysis, and so integrated reasoning ish, maybe that's the way they're making it sound, is going to become a much more important part of the exam than it currently is. I wanted to start getting more data discussion in our free prep hours because I was digging back through all of our free prep hours that we've got on YouTube. So if you're here live, you should absolutely be checking out our YouTube site where we have the recordings of all of these. If you've come to this link through our YouTube channel, definitely check out the entire playlist. But we don't have a ton of lessons on integrated reasoning or just data more generally. So what I wanted to do was start to kick off kind of a little mini series of lessons about data. And I thought a nice way to kind of start with that would be the part of data that most people are the most comfortable with. And I'd argue that most people are the most comfortable with the world of graphs. So what we'll do tonight is we're going to focus in on primarily the standard graphs, but start to look at the types of questions that we might be asked of graphs. Generally speaking, graphs in integrated reasoning up to this point have involved fill in the blank type questions. And so primarily that's what we'll work with tonight. But some of the common graphs that you might see are things like columns or stacked columns or bars or grouped bars. They might call those, so any of these might be called column or bar, depending on kind of the vernacular. You can have stacked bar, you can have clustered bar, you can have stacked column, you can have clustered columns. Line charts, pie charts, scatter plots, and then to some degree, things like bubble charts and Venn diagrams. We can certainly get weirder graphs that maybe we've never seen before and that we have to learn from scratch. But what I'd like us to start with is the space of graphs that are a little bit more comfortable, that we're maybe a little more comfortable with, and look at the types of questions that come with them. Yeah. So I want to start, I'm going to give you an entire question to begin. And so technically for our graphics interpretation, if they don't change the graphics interpretation format, then you'll get two blanks. Sometimes it's one sentence with two blanks that you have to complete, or sometimes it's two sentences each that have a blank. Now, when you're given the blanks, these will actually be little clickable boxes. So technically they'll look a little more like this. Right? So it'll be like a little box that sits there. And when you click on it, there'll be a drop-down menu that will list the answers. And one of the things that you want to really pay attention to with graphs problems is doing just that. Going in, clicking before you try and answer, clicking on the little box, and looking at what the possible answers are. Part of that is that you want to know how granular your answer choices are, how spread out they are, how much you can approximate, how much you can estimate as you're looking at the graph. So before we even start with sort of here's our process for graphs and here's our process for data, what I would love to do is give you a chance to try one. Yeah. So pie chart, off we go. Generally speaking, we'll be looking at about, let's say, 2.5 to 3 minutes. That would be kind of a good estimate for now. And as you get an answer, I'm going to invite you to type to me privately in the chat window your answer for each one as you get it. So you don't have to wait and answer both, but just give me your answer to each one as you get it in either order, whichever one you want to work on first. Yeah, so in integrated reasoning, whether you take it in person or online, you can use the physical whiteboard. If you take it in person, you'll be using the yellow pad. Great question. Okay, and keep letting me know as you get your answer. All right, I'm getting a lot of answers in for the first one. How about the second one? And we do, and I should have mentioned this, we do get a calculator, which is really nice. All right. Okay, so I'm going to cut us off. Thoughts on this one? So I want to take this as two pieces. So first question, how was reading the graph on its own? How was interpreting the graph itself? So that's where we're going to start. We're just going to look at the graph before we go any further. How was the graph? Easy, medium, or hard? Did you think? The actual graph itself. Easy, medium, or hard? Yeah, right. So one of the things is that for data problems, it doesn't always have to be the graph that's the hard part. So a pie chart for most of us is going to feel pretty easy. Now they could give us graphs or graphical representations that are quite complicated. And so often in those types of problems, all the work will come from trying to figure out the graphic. But if the table or the chart or the pie chart or the bar chart or the scatter plot is a pretty standard graph, then we need to be ready for the more complicated piece to come in the questions. That said, when it comes to data, what I want to encourage you to do is take the first anywhere 15 to 30 seconds, depending on how complicated the graph is. If it's a more straightforward graph, probably 15, 20 seconds. If it's a more complicated graph, probably 30, 45 seconds. I want you to take a little bit of time and notice all the parts. All right, so I'm going to kind of scooch this over for a second so we can see it. So when we say notice the parts, the first thing that might be evident to you is that it's a pie chart. But we want to make sure and look at all of our labels. So April sales for produce stand P. So at a specific produce stand, these are our sales. It's a breakdown. So great. And we have another little footnote that our total sales were a little over $4,000, $4,441. Not pretty numbers. And then when it says a breakout, what it means, and just as a reminder to not put your answers in the Q&A, but to put them in the chat window. And yes, we should always assume that a pie chart will add up to 100%. Yes. They're not trying to mess with you on that. A table doesn't have to, but a pie chart by definition does have to add up to 100%. Yeah, it's a great question. So we've got that total sales, or 100% in this case, is about $4,400. I don't want to be too specific, but again, we do have a calculator. And then what we know is how much of that, what percentage of that is for each type. And so one of the number one things that I like to do for any table or graph is I like to randomly choose a detail. So if it's a scatter plot, I pick a point. If it's a bar chart, I pick a bar. If it's a column chart, I pick a column. If it's a line graph, I find a point on that line graph. Or if it's something like a pie chart, I highlight one of the pie wedges. And I do that and say, okay, can I interpret what this means? And so I would say, okay, potatoes at produce stand P represent a little over 20%. Another thing to think about here is that's like 10% times 2. 20% of the total sales that were $4,441. I don't have to calculate that, but I would just say, around 20% or around a fifth. So I just want to make sure that I can interpret a point on my graphic somewhere, right? That's my first goal. If I can't do that, if I cannot comfortably interpret a point or a bar or a part of my graphic, then I probably shouldn't be wasting a lot of time on this problem. So one of the key factors of the GMAT now, and it will be a key factor on the new exam, is that time will be limited. And so we're still going to strongly suggest that you bail. In the world of the current test, integrated reasoning is one of those things where we tell people to be ready to bail on anywhere from 2 to 4 questions of the 12 that you'll see. And so if I've spent 30, 45 seconds trying to interpret a graph and I can't describe a piece or an element of it comfortably, that's a really good signal to skip the question and move to something else. But let's say, just like you all said, this was a very easy graph. It probably took you 20 seconds max to make sense of it. So we'll move into our questions. And you can do the questions in either order. Generally, I might look at ones that maybe the answer choices seemed really easy, but otherwise, either order is fine. Doesn't really matter. So we'll start with the first one. I think that's the one that everybody came to me and gave me an answer pretty quickly on. And so keywords, and these are going to get used a lot in the world of data. The word approximately, right? So approximately is a huge invitation to estimate. And generally speaking, you should be estimating whether they say approximately or not based on how spread out your answer choices are. Now, these answer choices seem a bit close, but they say approximately, which means that it should be safe to be rough with our computations. Again, we do get a calculator, right? So the fact that we get a calculator can be helpful. So I'll go ahead and grab my little Mac on-screen calculator. Note that the calculator you get is going to be pretty rudimentary. It'll look just like, basically like this one. There won't be many tools to it. Some add, subtract, multiply, divide. Okay, so approximately what amount in total sales? I look at my answers. I would click on it, look at my dropdown. It's dollar amounts. Approximately what dollar amount in total sales in April, okay, that's my month, came from the sales of apples, bananas, and oranges. So quick question for y'all. This is going to be apples, bananas, and oranges. Should I calculate each one of those first? So find 19% of my total, find 14% of my total, and find 17% of my total? What do you think? Is that the way to go? Yeah, I'm getting a lot of no's coming into the chat window. So what should I do? Instead of, I have one option. I could calculate apples, take 19% of this ugly number, plonk it into my calculator. I could take 14% of this ugly number, plonk it into my calculator, and write it down. Or I could take, and then 17% of this number, and then combine them all up. Cool. So I got another suggestion, which was like, well, no, instead of taking 19% of the total and 14% of the total and 17% of the total and then adding them, one thing just to prove that you can do this, if I were taking 19% of a total and I were going to add that to 14% of the total. And I then was going to add that to 17% of the total. The fact is I could, if I wanted to, factor the total out. And so several of you said, no, you should add them up first. You should add them up first. It's like, oh, okay. So one option would be to add up these numbers. Now, I wouldn't use a calculator for this either. What I might say is that 13% and 17% would be 30% with one left over to add over here. So that would be 30% plus 20%. But I saw an awesome suggestion in the chat window. If we look at these three together, pie charts are always drawn to scale. And it looks like this is a straight line. So if this is a straight line, then these three pie wedges look pretty close to, and if you added them up, you could prove 50%. And so if what I need is about half of this number is 2,220 and some change, we can get there without a whole lot of computation. So you will have a calculator and you will want to use it from time to time. But I promise you that with charts and graphs in this way, you want to start practicing eyeballing. Well, that looks like it's about half. Now, if you had a couple of numbers that were right here around 2,200, okay, maybe you'd want to double check and add them, but nothing else is close, right? If these are about half, 2,500 is half of 5,000. That's way too much. Okay, so now we've got the second one that's a bit more of a pain. It says if the sale of potatoes were to go up by $173 next month and all other items were held constant, right? So if I sold more potatoes and everything else was held constant, what would my new percent of potatoes be? Well, I want you to type to me in the chat window. I think this is the one that took folks a lot longer. And so how could we figure this out? And so now we're going to have to start talking about some of our stat formulas. How in the world, I mean, we could figure this out by saying, okay, I figure out 22% of this total. That's potatoes. Everything else, the 78% would be everything else. 78 would be everything else. And then I add the new amount to potatoes and then take the whole, right? Take that out of the new total, 4441 divided by, or plus whatever that 173 is. So what did y'all try? What did y'all try? And are there any answers that we could pretty quickly eliminate? What do you think? Nice, y'all. So I have a couple of people mentioning that if potatoes is already 22%, and we're going to add more potatoes, can we get rid of any of our answer choices? Yeah, we can. We can get rid of 20%. We know it's definitely not going to be 20%. And if all we're adding is $173, this isn't quite exact, but $173 as a fraction of our sales is only about 4%. Now that's of our current sales. That's not of our new sales. But adding $173 is really only changing even our current number by about a little less than 4%. which means our new bigger value. So if we were to think of, 173 divided by 4441 is going to be a little bit less than this like 3.5%. So let's just call it like, it'll probably be around like 3.5%, something like that. So I'm adding an amount of money that's really only valued at about 3-ish% to potatoes value that's currently at 22%. The only thing that would make, and this number would go down a tiny bit because potatoes, this 22 original amount is now over a bigger total. And so I can actually use estimation here to get to 25 because I know I'm not adding a whole lot. Right? I'm certainly not adding enough money to move potatoes from 22% all the way up, especially not to like doubling it. Or even at 35%. Now, if we did want to solve this formally, to do so, we'd need to say, okay, I need potatoes now plus the $173 that we're going to add to potatoes. So this will be like whatever dollar amount the potatoes are now. And I'm going to put that over the 4,441 plus that 173. To figure out potatoes now, I would take 22% of 4,441. And so we've got, and then I'm going to add the 173 to it while it's already in my calculator. Oops, plus 100. Oops, there we go. Let me try it. Let me back it all up again. So this is why I hate using the calculator, side note, because every time you keystroke something incorrectly, you have to start all over. So I multiply that times the 4,441. And then I'm going to add to it 173. So up top, potatoes are going to be worth about $11.50 over 4,441 plus 173 over 4,614. Now I got to go one more step and divide. So again, if I'm doing this sort of manually, this is not just slow, but this is very, as you've already seen, if I keystroke anything, and now I've got that it is in fact very close to 25%. So what I want you to start to note is, yes, we have a calculator, but in the same way that we use logic and intuition as we're dealing with the math section, like under the quantitative section without a calculator, we should be doing the same thing with data. Right? We don't want to get so glued to a calculator that now we're constantly having to key stuff in, again, with a mouse. And if you're taking the test on a laptop at home, you're doing all that on a keypad, on a trackpad. The only way you're allowed to have a mouse at home is if it's wired. It has to be wired into your machine. You cannot have any wireless Bluetooth peripherals. Okay, so just keep that in mind. Okay, so thumbs up, show of hands. Who is ready for another one? Who wants to see another question? Cool. Ready? Okay, killer. Let's do it again. So this time, I want you to force yourself to take a little time. Oh, I have the wrong answers there. Sorry, 1 second. I don't know why they're wrong. Okay, here we go. I'll fix those answers for you on the second one. And so I'll get those up for you, but I'd like for you to take about 30 seconds or so, 15, 20 seconds, working on just the graph, right? Just the graph. So can I pick a segment of a bar or the whole bar and determine, right? Like okay, what is this? Can I define it? Can I outline it? And so on. Yeah. Okay. And I'll get you the new numbers for the second one. I'm not sure why those weren't there, but I'll put them in for you. And then I'll get you a timer going. All right, there we go. Lots of good answers in. Lots of good answers in. Beautiful. Okay, how was this graph? Easy, medium, or hard? Are we still in the territory of easy? Moving maybe a little bit more to medium? Okay, that's some easy. Okay, so on this, we now have a stacked bar chart. And so generally speaking, when we have a stacked or clustered or grouped bar chart, then we will be given a little legend that explains which color or pattern is which. So total produce sales, this is monthly sales for produce stampede by category, by vegetable versus fruit. We will also assume in this case that that is total. Although the test may be more specific than I just was, and they may actually call this total. But generally speaking, we'll take this as total. And so total produce sales were greater than 4,600. So now I have to eyeball this. So if this is my midpoint, 4,500, then I need to figure out which ones of these, and if I split this next difference, right, that would actually be 4,750. And so they're not trying to mess with us, not entirely, right? Like, I mean, they're not always our friend, but they're not entirely trying to mess with us. But what we can look at is say, okay, with sales greater, any of the ones that have sales greater, that would actually be these two little short ones appear to still be tall enough to be at that 46 or above. And so it's going to be all of these months. You could count them 1, 2, 3, 4, 5, 6, 7, 8. Or you could take 12 and subtract the 4 that are clearly below. But our correct answer for the first one is just read the graph and count. So note that if the graph is ever so slightly more complicated, sometimes the questions themselves are a bit more straightforward, or one of them is a bit more straightforward. I'd say in this case, both of them are. They're both just asking you to read the graph. And so total vegetable sales were approximately what amount in September. We have to know that we have to come and read September. We have to count all from middle, like the whole stack. So total, well, and this is just total vegetable sales, so we only want the top half of the stack. And so generally speaking, what's often easier to do, you could take the whole stack, that's all 5,000, and subtract, so we know it's not 5,500. And we're going to subtract off the about 2,500, that is the fruit sales. And so it's going to be about half. And so our correct answer is 25. So we've got 8 and 25. So good. I want to round out the bar charts, or the more straightforward bar charts, with a grouped bar chart. Let's just do a single question for this one. It is a slightly different graph, so make sure that you understand how this graph is displayed. Same information as the last one. It just turns out that it's basically giving us that information in a slightly different format. So take a moment to kind of internalize that, and then let's see if we can't get this one question done in about 2 minutes. Send me your answer when you think you've got it. All right, so I've only got a few answers in. And one of the things I want to check in on is that how many of you, and let's go maybe show of hands, how many of you looked at the possible answers before you started solving? Okay, nice. And how does that help? So I've got two folks that did, and it really is a good idea, particularly in a problem like this one. How does that help? What does looking at the answer choices first give us in a situation like this one? You can type in the chat. Yeah. So if I was trying to figure out which month had the largest percentage of vegetable sales, so if I calculated the total amount of vegetable sales for every month, and then I counted the total overall sales for every single month, and then to get the percentage, it is, dollar amount of vegetable divided by the dollar amount of vegetable plus the dollar amount of fruit. Now, I don't want to do that for 12 months. I really don't. Now, certainly, if we feel a little bit comfortable with the data, we might be able to narrow some things down. But even better, if we're given a limiting answer choice already. So what I know already is that I only care about January, March, June, October, and November. Now let's stop for a minute and think about what we're trying to come up with. I want this fraction to be as big as possible, right? So I want this fraction to be as big as possible. So if I'm trying to make a fraction big, what would I do to the numerator and or the denominator to try and make a fraction really big so that we can start to think what are we looking for here? What would I be looking for? Exactly. So if I have a fraction and I'm trying to make a fraction bigger, I make it bigger by increasing the numerator and decreasing the denominator. However, here's the problem. As I increase the dollar amount spent on vegetables, that's going to increase the dollar amount spent on vegetables down here. So what I'm looking for, though, to kind of balance that out is I want the biggest vegetable relative to the smallest fruit I can possibly get. So given my 5 possible months, I can automatically eliminate 3 of the 5 of them. Because if I look at January has higher vegetable than fruit. Good, that's what I want. I want vegetables to be high and fruit to be low. March also has higher vegetables than fruit. But June is the opposite relationship of what we want. And October and November are equal. I want a situation where I have more vegetable sales than fruit sales. And so I can eliminate June, October, and November without having to compute them. That's what we're looking for. And sometimes that might get me down to a single answer. But what I need to do now is try and I have a couple of options, but what I'd argue is that the bigger difference, right, is happening in January. There's a larger difference than this little difference here. And that larger difference is over a smaller total. But I would still potentially on test day, because I do have my little calculator, I would test it. So January, vegetables are about, just about 2,200. So I'm going to divide that by 2,200 plus my fruit sales that look like they're about, let's call it 1,700. That's not quite right, but close enough. And I'm going to compare January to March, where March has a higher numerator. That's getting close to 2,300. And so that's going to be 2,300 plus, this is about 1,900. Okay, so I've got 2,200 plus 1,700. So that's going to be 3,900 total in sales. 2,300. I hate the online calculator. It's the worst. 2,300 plus 1,900 is 4,200 in sales. And so I've got 2,300. I'm going to kill off some zeros here. I got 2,200. I'm going to kill off some zeros. So my options are 22 divided by 39, which is 0.564. So 56.4%, or 23 divided by 42, which is 0.548. And so January is our winner. Yes. Because vegetable sales, so it would be like, notice that these will say January, right? So January had the largest percentage of vegetable sales relative to total sales. Because vegetable sales would be in that month, then the total sales would also need to be in that month. Yeah, exactly. Okay, nicely done. All right, so then let's do it again. This is going to be a slightly weirder version of a bar chart. Again, one question. Before we look at, I know we're kind of bumping into time, but I want to get us through some of the kind of like family of bar stuff. So let's give this one a go. Again, let's look for, because it's just one question, let's look to get this one answered in about 2-ish minutes. All right, so notice that on first glance, this appears to be a bar chart. However, it's a bar chart that's really talking about percentages. And so if we look at 100% of sales, and let me zoom us in just a teeny bit more. If we look at 100% of sales, you might say, all right, I'm going to pick one of my bars this month. So July would appear to be a month where there was exactly a 50-50 split between vegetables and fruit. Whereas in other months, maybe there was more vegetable sales in January, but slightly more fruit sales in June, for example. So the question said, if the total produce sales in July, so total produce would mean the total for the pear. So if the total produce in July were $4,500, so if this 100% was $4,500, then the approximate total fruit sales, right? So we've got, if the total produce sales in July, right, were 4,500, then the approximate total fruit sales in December, wait a minute. Hold on. Now, if this had said the approximate total fruit sales in July, then the answer would be half. Because fruit sales would be half of this 4,500, which would be about 2,250. But that's a little weird because 2,250 is the exact same distance between these two numbers. So how would I know which one to pick? It's because the answer isn't, in fact, either of these. I know what the produce and I know what 100% represents in July. In July, that number is 4,500. But I have no idea what 100% in December is. 100% in December could be $1,000. It could be $5,500. It could be $1 million for all I know. Note that this table doesn't give us dollar amounts. And so for any of these data points, I'm going to have to be told, what does this 100% represent? I know that in December, right? So in this case, if we had thought, oh, is this 4,500? And so fruit sales are a little less than half. And so you'd want to go 2,200. However, I don't know that this is the total for December. And so because I don't know that this is the total for December, actually, I'll leave that. The correct answer is actually that it cannot be determined. So be careful with some of our tables, right? Like the left column is percent of total sales. So I know that in December, fruit made up a little less than half, but a little less than half of what? Okay. So I want you all to type into the chat window. What is the lesson for yourself? Because nobody got this one right. I got a lot of answers and none of them are right. What is the lesson that you're going to take from this question to prevent you from missing it next time? Yes, pay attention to the axis labels. Such a good recommendation. Yep. Rechecking the graph again. Make sure that you kind of know what you're taking those percents of, or what do you know and what don't you know. All right, let's try one more. Let's try one more. We're going to move off the bar charts. Is that true? Yeah, let's do it. Let's move off the bar charts. Let's do a line chart. Yeah. Let's look at a line chart. And since we got 2 questions, I will give you the full 3-ish minutes to answer them both. So we'll end on a little bit of a challenge. Okay, I've only got a few answers. Okay, take another moment to send me your answer if you haven't yet. All right, so let's look at how to interpret this one. They were really nice actually with this line graph is that at each point for each month, they actually typed out the number. They'll do that sometimes if the estimating is hard, right? Like notice that this isn't granular enough in some ways. Okay, so let's start. The first one seems a little shorter. The second one seems kind of a mess. So the approximate percent increase in total sales, so this is total monthly sales, from January. So here's from January to June. So the approximate percent increase. So one thing to note that when we're dealing with data, we are still dealing with things like average, percent change, percent of. So your fractions, decimals, percents, your average, your range, your median, those things are going to be really important when dealing with data. So the percent increase is essentially, right? So percent change is the percent difference, or the dollar amount difference, I should say, excuse me, the dollar difference in this case, divided by the dollar, in this case, where we started. So first I need to figure out the difference. That's going to be the 5,143 minus 3,890. And that's going to be over the starting amount, 3,890. So 5,143 minus 3,890 equals, divided by 3,890 is going to be about a third. And we're looking at about a third. And so the only answer choice that's close to about a third, so technically we kind of could have stopped, is here. Notice I would have, as ugly as these numbers are, I probably would have punched them into my calculator. Another trick so that there's fewer numbers to punch in, you could split the numerator here. So the new minus the new divided by the old minus, if you were to look at 3,890 over 3,890, that's just going to be 1. So note that you could still do 5,143 divided by 3,890, and then you're just going to subtract the 1 off the front. So it's one fewer thing to have to plug in. So we're looking at about 32%. For the second question, though, if the average sales per month, so meaning if I added all of these up and divided them by 12, the average would be 4,725. So let's write what that means for a second. It's the sum divided by, so the sum of all of these numbers divided by 12 is 4,725. However, let me move this out of the way, in January, the sales were supposed to have been 4,072 instead of 3,890. So the sum was actually too small. My sum should have been larger. Yeah, my sum should have been larger. And so my average should also be larger. Well, that doesn't help me too much because all of my answer choices are larger. The question now is how much larger? So there's a trick. What is the error? Well, we screwed up. So 4,072, if I subtract the 3,890, I missed $182. And so technically what I need is to add $182 to my sum and then divide it by 12. So there are a couple of things we can do here. One thing we can do is to say, and I'm going to move off this screen for just a moment, just so we can have these numbers, right? So if I have my original sum over 12 is 4,725. And I'm trying to figure out my new sum plus whatever that amount was, $182 over 12. What does that equal? We have a couple of options. One option is to calculate our sum. So I could say, all right, well, the original sum would have been 4,725 times 12. So the new sum, and I'm going to write that down, 56,700. I'm then going to take that, I'm going to add 182, see, 182 to it, double check, yes. And then I'm going to divide that number by 12. So my new, right, so if I plug this in, the new average is 4,740-ish. However, we can also take this expression and say, well, if I were to split my numerator and say that the sum divided by 12 plus 182 divided by 12 is going to be my new average. Well, I know what the sum divided by 12 is. That's this original average. That's 4,725. So what I need to figure out is, what is this increase in 182 going to do to my average? So what we're doing is we're basically saying, what's the change in my sum? Let's spread that out over 12, right? Let's pump that through the average formula. So now if I go this route, the only number I have to punch in my calculator, I don't have to punch all of this, then plug it in, then add it, then divide it. The only number I have to punch into my calculator is 182 divided by 12. So I need to add, $15 to this amount. And so I'm going to go look at my answer choices and go, okay, so 182 over 12, that's $15. I need the number that is 47.25 plus 15. Well, that's 47.40. I'm going to use my answer choices to help me get there. Now, we did a YouTube video about really tricky kind of like stat stuff. And we did a cool one with GMAT Club about all these sort of fun, weird weighted averages and stats. So check that out on our YouTube channel as well. But I will be doing more of these data sets. We'll be looking next time at some more complicated graphs and like weird, strange graphs. And also kind of digging into some of those strange math they might expect you to use when you're dealing with graphs. And then we'll look a little bit more at things like MSR, the tables. We might start looking at all of the two-part pieces. So lots more data to come over the next few months as we're trying to get better prepared for the new exam. I just wanted to let you know that, as always, we have lots and lots and lots of free stuff available for you online. And so if there's anything that you need help with studying, you can always sign up for any of our sessions, first class, for free. And so you can do that by coming to our website. So if you just go to manhattanprep.com, you go under GMAT to GMAT Prep. Under GMAT Prep, you can always come and check out our live courses or our on-demand self-study toolkit. But if you come into our free section, you can sign up for any, just like you signed up for tonight's free prep hour if you came. You can sign up for any of our free upcoming classes, free trials, questions about which test should I think about taking, also the work that we like to do with MBA Mission. So this is an example of a workshop where, let's say you work for a family business. Like, how do I talk about the fact that now the people I work most closely with might be family. And so how do I get them to write a letter of recommendation? I mean, I can't. So what am I going to do instead? So we've got all of these. One other cool series of events that we also have are free Foundations of Math. We've just fundamentally changed these, which is awesome. And so if you try out our new Foundations of Math, heads up, they're now, instead of a single 7-hour, they're 2 5-hours. So you get 10 hours worth of Foundations of Math. We've got them separated into 2 types of lessons, and we offer them sort of alternating. So you'd want to click on those course details to see, but we offer a section on more of the algebra, variables, and that kind of mechanics. And then we offer one on, we call it computation, but it's all about how to do fast, effective computation, estimation, things like, working backwards, plugging in your own numbers, and thinking about kind of like understanding how numbers work so that you're not feeling like you're lost without a calculator. Yep. So please come hang out with us. All kinds of free stuff that you can try. Otherwise, I want you to have a lovely, lovely evening. Oh, and yep, our the Manhattan Prep YouTube channel. Yep, we always post. Yep, we always post the newest video. It usually takes us a week or so to get them up, but all of them, they're chronological. So if you go to our Manhattan Prep YouTube channel, and I'll pull it up for you so that you can see it. Let's see if I can make sure it doesn't just start playing sounds of me. Good, I've got it muted. If I share the screen, if you come to our YouTube channel, and you can find that, right, Manhattan Prep GMAT. If you come to our YouTube channel, you can come down and just look at videos, but the easiest way to do it is to go to our playlists. And under playlists, we've got our full GMAT prep hour. I also want to highlight for you, and I'll show you that full list in just a second, all of these math spotlights, the expert, the intermediate, and the foundations, are individual questions that you try, and then we go through them together. So there's 6 or so videos in each one of those. And so those are really cool options if you're looking for some practice questions. But these are in, I know that like this one might be a little bit, I don't know why that one says 2 months ago, but generally speaking, our newest ones, we've got a couple that we're sort of behind getting up on, but for the most part, they should be in order of the newest ones. Again, I don't know why that one's here at 2 months ago. It may have taken a little bit of time to get posted, but generally they are posted in order. I think we have 3 that are still processing to get put up, but yes, they will be there. Yep. All right. Thanks so much, y'all. Have a wonderful rest of your evening. Take care. And I can't wait for us all to find out more about this new test. It's going to be cool. We'll do it together. Have a good night, y'all.